Good morning, good afternoon, depending on where you are. This is Sharon Fitzpatrick, and I will be your host for today's webinar, Elastic App Visibility in AWS Public Cloud. Our speakers today are Praful Badazna, the Senior Director of Product Management at Big Switch, and Jagdish Akla, the Technical Marketing Engineer from Big Switch. So before we get started, what the goal of today is to answer the question, is your cloud cybersecurity compromised due to lack of visibility? We know that that's a really important topic, and according to the 2018 Cyberthreat Defense Report, 9 out of 10 IT security professionals acknowledge that cloud security challenges are top of the list. So let's dig into the content. The next thing I want to tell you is how you can talk to us. If you have a question, you want to know some information, please go to your dashboard, and there's a questions tab that you can go there as well. You can ask a question, you can ask us for information, or you can email us at info@bigswitch.com. At this time, what I'd like to do is turn it over to Praful to get us started.
Thanks, Sharon, and good morning, all of you guys. It's great to be back here and to talk about Big Switch's cloud-first strategy and how it relates to Big Monitoring Fabric. Before I go about talking about that, I wanted to give a quick summary with regards to the public cloud landscape that we are seeing. So we're seeing a lot of traction on the public cloud. More and more enterprises are moving to it. And none of this should actually be something new to you guys, but this is just to validate that this is what we are seeing. More and more enterprises are prioritizing deployments on public cloud. And when we are talking about the public cloud, it's not just a single cloud. They are looking at multi-cloud strategies, which, by the way, also includes hybrid cloud. So you have already workloads on your current enterprise data center. It's not going to shut down completely as you move to the cloud. There's going to be a time and place where certain workloads will be on the cloud, certain will be on the enterprises. So in that scenario, how do you keep the simplicity, have that operational workflow to manage both the environments? More and more enterprises have increased their spend, and they have a significant spend for public cloud deployments. And so much so that they are now either having or very closely considering having a central cloud team to help manage all of these requirements for the cloud environment. And we are seeing customers have their enterprise IT teams shift their roles a little bit with regards to the public cloud, where they are looking more on the governance and how do you broker cloud deployments. That said, among all of these things, there has been a single most top challenge with regards to public cloud deployments, and that has been with security. The question is, security by itself, when you had workloads only on your enterprise, was a hard thing to do, with the attack surface for the organization being multiple different places. And now when you're moving to the cloud, that attack surface has increased even further. How do we secure across all of these? And when we look at the key top concerns from most enterprises, security is at the top. When we're talking about security, people typically have a few questions that, okay, how do I design my defense mechanism against attacks? And how can that defense be agile so that I can enable it very quickly and I can scale down when not required? How can we make it consistent and reliable so that security is visible at a consistent manner? And finally, the way most organizations know about doing this is via visibility onto their packet or flow level workloads. So if you can get packet or flow level information consistently, pervasively from your network, you will be able to do this. The question now is, how do we do that for the cloud? In order to get that sort of information, it is very important to understand that you need to have visibility within your production network. So pervasive visibility is no longer optional. To deal with security, you need to have visibility. Now, for a hybrid cloud deployment, you have your data center, you have your mechanisms for monitoring your production data center on the enterprise or private cloud. And then you have your public cloud environments. Immediately, you will see that the way you're going to troubleshoot on a private cloud would be way different than on public cloud environment. So one is on your public cloud environment, you're not going to have complete support for packet level visibility or flow level analytics. And this will basically cause disparate workflows across on-prem deployments as well as public cloud deployments, which makes it very hard for you to come up with a consistent security view for an organization. Now, what we are talking about with our cloud first vision is to have analytics everywhere and to have the same amount of information consistently sent to analytics, irrespective of where your workloads are residing. So for an enterprise or a private cloud, we will be able to send flow as well as packet data to analytics. And we will be able to do the same for a public cloud deployment. The management, the orchestration, the troubleshooting across your enterprise and the public cloud would remain same. This makes it very easy for you to deal with hybrid cloud deployments in your organization. Now, if I contrast this to a traditional network packet broker, immediately we see multiple different challenges. A traditional network packet broker is box-based, and all your management is done on a box-by-box level, which sort of gives rise to complexity as you scale higher and higher and higher. And there is a proprietary factor also associated with it. And if you look at it, for any organization right now, their main goal is to innovate quickly, have agility, keep it simple because the data center is growing quickly and fast, and still have some choice in terms of what hardware to use, what software to use, so on and so forth. All of these goals are typically not met by the traditional network packet broker. With the Big Switch solution, and Big Monitoring Fabric in particular, we are able to do that. The way we are able to do that is we have a software-defined architecture which can run over industry standard hardware, be it open networking switches, or be it x86 servers, or be it virtual environments, or be it cloud environments. Doesn't really matter. You have the same architecture across these different set of platforms. This gives you a tremendous ability to have programmability and automation for your monitoring of visibility. It gives you tremendous velocity to innovate, and also reduces your CapEx as well as OpEx costs. And if you look at it, given that we have the same architecture, so this is a screenshot of multiple private cloud deployments using Big Monitoring Fabric Enterprise Cloud. And then on the top right, you have the Big Monitoring Fabric Public Cloud, which would be available for AWS, which is already available for AWS, and would be available for Azure and other clouds in the future. The way we would provide a single pane of glass across all of these environments is via an element called MultiCloud Director. MultiCloud Director will be sort of the single pane of glass entity that would manage all your private cloud or enterprise cloud deployments, as well as public cloud deployments. Given that this would be a single pane of glass, it'll be able to provide you consistent workflows across these different deployments, and also provide you complete visibility irrespective of where your workloads are residing in your enterprise. Now, this architecture is useful because the enterprise cloud, which is your on-prem deployment, is actually very scalable by itself. So let's quickly have a look about how it works, right? On the left-hand side, you have your production network, and on the right-hand side, you have a single centralized tool farm where all your tools reside. The goal is to take traffic from your production network either via tap or span. That means it's a replication of your production network traffic, and give it to one or more tools. And in order for you to be able to do that, we can have a switch fabric sitting in the middle with one switch, two switches, or as many switches as you want, where you can do filtering, aggregation, load balancing, replication, so on and so forth. Now, given that you can have multiple switches sitting in the middle, what we have done is we've created a controller technology, the Bigmon controller, which sits right on top, and then manages this fabric of switches as a single logical big switch. And that's how the name of the company is. So contrary to popular notion that as scale increases, complexity increases, you can see with this architecture, complexity always remains at the level of a single logical big switch, irrespective of how many physical switches you have in your fabric. Now, if you want to have advanced packet functions, for example, deduplication, packet slicing, header stripping, so on and so forth, we will use Bigmon service nodes, which are, again, a DPDK-enabled x86 server-based appliances, which connect to the switch fabric. But more importantly, they are still managed via the controller. So as I'm adding more switches or even more service nodes, my complexity is still that of a single logical big switch. Now, if I expand this further to having remote sites visibility or sending to tools which are at remote sites or cloud, I still maintain my management to a single pane of glass, which is again going to be the controller. So you can see that as we are increasing function, as we are increasing pervasiveness of visibility within the enterprise, simplicity still remains as if you were just monitoring a single rack or a single server. Now, what we've done is, after this, we've gone a step further and we've introduced two new appliances, which are Bigmon Analytics Node and Bigmon Recorder Nodes. The architecture behind them is again similar, that you can have one or multiple of them still managed via a single pane of glass, and that gives you the simplicity, ease of use, and you have a big logical analytics node or a logically big recorder node. But the most interesting aspect of all of this now is the end IT workflow for the customer. If you, from a customer perspective, you want to know what's happening in your production network. For that, you could get some information from analytics, and based on that, you may say, hey, I actually want to get to the packet level detail, which could be on the recorder node. Now, traditionally, without Bigmon Analytics Node and Recorder Node, this would actually be a manual process where you go to the recorder, get some files, create a PCAP, put it on a server, send it, SSH it to a tool, analytics tool, where they could do further analysis. With this integrated solution, where you have the analytics node, the recorder nodes, and the network packet broker fabric, it all boils down to a single operation. You go to the analytics node and say, okay, I want these packets from this time to this time from the recorder nodes, and boom, we will make it happen, leveraging these three in unison. So the end workflow for any IT troubleshooting tasks for any enterprise becomes dramatically simple. Now, if you say that, hey, if I have packets on my recorder and I want to send it to a analytics tool, which is not a big switch one, so long as that analytics tool is connected to this big switch network packet broker fabric right here, I will be able to take those flows, packets, and send it to any tool through our NPB. This is the power of this integrated solution of the network packet broker, analytics, and the recorder node. And the reason I'm explaining all of this is what in essence you will find in the cloud too. This architecture is built in a way that it would work for a private cloud or even a public cloud environment. I've touched upon the key value props for our cloud-first architecture for Big Monitoring Fabric, and this just summarizes it. We are we use industry standard hardware coupled with our SDN technology. We have an analytics everywhere approach. As you can see, that anything that came into the Big Monitoring Fabric could be sent to an analytics. You have complete visibility, either using S-flow or NetFlow or packet metadata. We have an approach that scales out tremendously, but at the same time doesn't make it more complex as you scale out. It keeps it simple. It's completely programmable, and you still have that single pane of glass no matter how big or how small your monitoring fabric is. And finally, we have this differentiated offering where we have integrated various components of the Big Monitoring Fabric. For example, the network packet broker function, the analytics function, and the recorder function to provide complete simplicity with regards to your end-to-end IT workflows. Now, taking that context, let's look at how we can deploy in the cloud. So on the cloud, you have your instances. Now your instances could be in one or multiple subnets, which could be in one or multiple availability zones, which could again be in one or multiple VPCs. There are various different challenges with regards to seeing what traffic is flowing through at each level, either inter-instance or inter-AZ or VPN traffic or external traffic. How can we take traffic from these various points and give you visibility with regards to what's happening in your cloud environment? The way we do that is we create a separate VPC, and let's call it the monitoring VPC. This by itself now gives you a simplified, centralized monitoring for your AWS workload. And the thing to note here is, while it's giving you the centralized monitoring for your AWS workloads, it is not doing it in a siloed manner. I can get traffic from multiple VPCs or multiple instances and send them to the same tool. That's why we have built a separate monitoring VPC. So you are no longer just seeing information for your VPC or for a single instance to a single tool. Once we have this deployed, what we will automatically do is we will start discovering these various entities. So instances, subnets, VPCs, so on and so forth. And then the user will now have that visibility on the UI by which he can now create a policy to monitor one or more VPCs, one or more instances, and send it to one or more tools. So when he creates a policy, if the instances do not have the agent installed, the agent's purpose here is to basically replicate the traffic over a GRE tunnel and send it to the Cloud Light VX switch. So if the agents are not installed, we will automatically do this. So all of this is, again, keeping in mind it's completely simple, and the user doesn't need to really be involved in installing the agent at any point in time. So we will automatically create the agent, automatically create the rules for a Cloud Light VX, which is a virtual switch in AWS. And then once the policy is created, you will start seeing the flows move on from your workload to the vSwitch, the Cloud Light VX, then to the tool. And this would give you the same behavior or the same experience as an on-prem flow level or black packet level visibility that you are used to. The question at this point in time people may have is, hey, what if my workload traffic bandwidth has increased? In that case, we will elastically scale our virtual switch. The way you would do that on an enterprise or your on-prem deployment, add more switches as you want more bandwidth of traffic to be monitored, we will do the same thing for the cloud. And once that is done, the green arrows now show you the traffic flow of the replicated instances traffic that goes from your instance to the Cloud Light VX, the virtual switch, and then it goes to the tool that you have decided in your policy. All of these green flows, the green line would go over a GRE tunnel, because as you know, in AWS, everything that moves across VPCs will be GRE encapsulated. So with that, I've given you a very good high-level view with regards to how we do monitoring, not only for your public cloud, but also for your private on-prem, and given you some visibility with regards to how both of them can still work together, giving you an excellent hybrid cloud deployment experience for your monitoring.
Hi, my name is Jagdish Aulak. I'm the TME for Big Monitoring Fabric. So today we are going to demo how to get packet level visibility from a customer production workload in AWS. Before we jump into the actual demo for BigMon Public Cloud, let's briefly go over our demo topology. As we can see, we have two workloads, Ubuntu Workload 1 and Ubuntu Workload 2, that are deployed in a production VPC. We will have ping session between the two workloads going from Ubuntu Workload 1 to Ubuntu Workload 2. So using CloudFormation template, we have deployed the monitoring VPC. As you can see on the monitoring VPC that we have two subnets. One is a BigMon subnet and the other one is a tool subnet. On a monitoring VPC, we can see that there are two subnets. One is a BigMon subnet and the other one is a tool subnet. On the BigMon subnet, we have the Cloud Light VX virtual switch and the BigMon controller. And on the tool subnet, we have a Bro IDS which is deployed. Now, in order to get visibility into the customer workload, we need to create a policy. When a policy is created, a VPC peering connection is made between the monitoring VPC and a production VPC. And then the controller will check to see if a Cloud Light AX agent is installed on the workload that we want to monitor. If not, then the controller will automatically install the agent on the workload. Once the agent has been installed, the controller will then go ahead and push the policy configuration to the Cloud Light VX virtual switch. Then the Cloud Light AX agent will replicate the traffic and send it to the Cloud Light VX virtual switch over L2 GRE tunnel. Once the traffic gets to the Cloud Light VX virtual switch, packet filtering, where the packet filtering is done, and then the Cloud Light VX virtual switch will forward the traffic to the tool, again, over L2 GRE tunnel. Now let's see how this is accomplished using BigMon Public Cloud UI. In order to log into the controller, we need to get the public IP address, which gets assigned to the controller instance. We get this from the AWS console. As you can see from the AWS EC2 dashboard here, we have BigMon controller, Cloud Light VX virtual switch, and the Bro IDS, which has been deployed using the CloudFormation template. If we go to the BigMon controller, we'll just copy the IP address, open the browser, and HTTP it to the public IP address that we just got. Once we log into the controller, we get to the Big Mon controller dashboard. And from the dashboard, we can see that all the inventory, a brief overview of the inventory that the controller has automatically pulled in for the entire customer account. We see from here the fabric, number of virtual switch that have been deployed. In our case, we have one virtual switch, which has 64 interfaces. The big tab will display number of policies, filter interface, and delivery interface. Right now, we have not created any policies since we have just deployed the solution. So there are 0. And if we look at the cloud tab, we get an overview of number of VPCs, subnets, monitorable instances, tool instances that the controller has pulled in. If we navigating to the cloud page, here we see the detailed inventory information which the controller has automatically pulled for the entire account. We see that all the VPCs that have been deployed in the customer account that has been pulled in by the controller. So if we log in, if we drill down into one of the VPCs, we'll see the subnets, the monitorable instance, the tool instance that's been deployed, virtual switches, and controller instance. Since we are looking at the monitoring a VPC, we see that the tool subnet and a BMF subnet that has been deployed. If we notice that the virtual switch and the controller instance are both residing in the same subnet. Next, we're going to look at the production VPC that the controller has pulled. We see the subnet and all the monitorable instances that are in that VPC. Similarly, the controller has pulled all the subnets for the entire account. For the monitorable instances, these are the instances that can be monitored by the Big Mon controller. If we drill down into the instance, we see the network interface that are associated to with the workload. If we notice here that we have one of the instances that is in a stop state. Now I'm going to go back to our AWS EC2 console, and we see that the workload 3 is actually in a stop state. I'm going to actually start this workload, and we'll see that this inventory is properly populated in our controller. So now we see that the workload is running. If we go to the controller, do a refresh, and we see that the state of the workload 3 is now in a running state. Now I did this refresh, but if we go up here, we can configure the auto refresh interval to whatever desired value a customer wants. So that way we don't have to do it manually. The tool instances actually display all the tools that have been deployed. In our setup, we have only deployed one tool in that subnet, so hence we only see a Bro IDS tool that has been deployed. And then finally, we have the agents. Currently, we don't have any agents deployed since we have not created any policy. Now let's go ahead and actually create a policy and see the traffic flow from our workload to the tool. So before I create a policy, I'm going to go ahead and log into the instance, the workload, and the tool instance. So this is my workload 1. I'm going to start a ping session between workload 1 and workload 2. So the IP address of the private IP address of the workload 2 is actually 10.0.0.170. And this is my this is my tool. If we do an ifconfig, we see that we have one interface, and the other one is a loopback. I'll do a TCP dump. On the ENS5 interface. And as we can see, we don't see any traffic on our tool instance because we have not created any policy yet. Let's go ahead and actually create a policy. So creating a policy is very straightforward and simple. Just add a policy. We'll give policy a name, demo. We'll select the desired rule that we want. In our case, we'll use ICMP since we are sending the ping packet between the workloads. And the feeds. For the feeds, a user has the option to select the entire VPC, subnet, which has been discovered by the controller, or a particular instance that a customer wants to monitor. So we will select one instance that we want to monitor. We can filter the instance that we want to monitor. In our case, we want to monitor the workload 1, Ubuntu workload 1. We'll select that, append it, and next we select the tool instance. We only have one tool instance here, so we'll go ahead and select that. And then we finally create a policy. Now the policy has been created. Let's look at what has been configured actually. If we go to drill down into the policy, the demo policy that we created, we'll go down to the configuration. Under rules, we see that the rule that has been pushed down to the virtual switch, which is the ICMP. The instance that we selected to monitor, in our case, we selected the Ubuntu workload 1, and the tool instance, where the traffic will be sent to. Now, if we go back to the cloud page, we see that the controller is in process of installing and starting the agents, which were not there before. So on the tool instance, we see that the agent has been installed and started. And on the workload, the agent has been installed. It takes a couple of seconds for it to start actually. Now we see that the agent on the workload has also started. Now let's go back to our workload and our tool instance. Now we can see actually that the traffic has been forwarded to the tool. If we notice that we are seeing actually a GRE encapsulated packets since we are monitoring the ENS5 interface. So I'm going to actually stop this. I'll do an ifconfig again. Now we see that a tab 0 interface has also been created. When the agent is installed and started actually on a tool interface, a tab 0 interface is created. This is the interface where the packets are actually decapsulated and sent to the upper layer applications. Let's do a TCP dump on this. As we can see right here, that now the packets have been decapsulated. These packets don't have any GRE headers. Going back to our policy, if we go back to our policy, We can monitor the interface stats. Or we can monitor the policy stats. So that was a brief overview of how we gain visibility into a customer production workload using a big bond solution.
Thanks, Jagdish. At this point in time, I did get a few questions, so I wanted to make sure that I address them as part of this webinar. So most of the questions have been with regards to public cloud environments, like which public cloud providers do you support? Do we need to have agents on every instance? Is there an easier way? Can we have an agentless architecture? So on and so forth. So let me try and answer these questions. So we currently have a solution out with AWS, and we are working with Azure on an agentless based monitoring approach. Azure will look to Azure for the announcement on when that will be released. And once that is done, if you have any other requirements for any other cloud providers, please let us know. We will then look into that. AWS currently does not have an agentless based monitoring solution, which is why we need to have an agent deployed at every instance. However, given that fact, what we've done is we've tried to make it as simple for the customer as possible. As you saw from Jagdish's demo, all you had to do was just create a policy, and then behind the scenes we would take care and see if the agent was not on the workload being monitored. We would actually go ahead and deploy the agent automatically. So from the customer perspective, there is almost zero effort to install an agent on an instance or not. Furthermore, when you are monitoring in AWS, we give different levels of monitoring. You can go ahead and just select the workload for monitoring, or you can go ahead and even select the VPC for monitoring. And when you do that, then any workload that comes up in that VPC, you will begin monitoring that. So we've put in such places where we've tried to look at what would be the customer use case and how do we simplify it so that they get more and more visibility in a very easy manner.
What do you think the trends are going to be for IT security professionals? How important is the cloud going to be?
Oh, it is very important because organization, as I showed in my first slide, more and more organizations are going into public cloud deployments. That some organizations are going full out, some are moving part of their workloads to the cloud. But every customer that I have spoken to has either begun on this journey or are very close to beginning this journey. So there is a tremendous level of excitement with regards to how we are going to operationalize this once this moves to cloud. How do you make it secure, and how do I get the visibility that I have on my on-prem data center and still be able to manage that in the cloud environment?
Great. We have a question from the audience. If a threat is detected by the policies, what is the elapsed time for recognition?
So that depends on the tools that are being used. We are also, as we have the analytics tool for the on-prem as well as the recorder for the on-prem, we are looking to see how we can leverage that and have that in the public cloud environments too. So once we have that, probably we can give you a clearer answer, because then we would also own the tool instance. But otherwise, it depends on the vendor who's providing you the tool.
We had a question coming from the audience, and you answered it, but I thought it'd be great to share it with the group. Have you tested out third-party tools for advanced packet feature, SSL, decrypt, etc., in AWS in conjunction with BMF?
Well, we are in the process of testing multiple tools. What we typically look at is there a customer associated behind the testing effort that we are doing? So far, we've tested Riverbed AR11 with our Big Monitoring Fabric cloud deployment, and then we have a few other tools that we are looking to prioritize. So if you have any specific tool that you would want us to look at, please let us know, and then we can talk with you and then see if we can help prioritize testing of that particular tool.
Feel free to just send us an email, info@bigswitch.com, and we can answer that. So we're running really short on time, so what I'm going to do is wrap things up and say thank you very much for joining us today. I thought we got some great insights. And one of the things we have available for you is BSN Labs and our Community Edition. You can experience Big Switch solutions firsthand from the comfort of your PC, or you can evaluate Big Monitoring Fabric or Big Cloud Fabric on your network today. So to get to BSN Labs, we've included a handout, but you can do this firsthand from the comfort of your PC, testing it and giving it a real test drive, because we think that's the best way to get to know all about our products. We will be taking kind of a break for the holiday season, but we'll be back in January with a webinar. But meanwhile, if you'd like to go look at any of our webinars on demand, all you need to do is go to bigswitch.com/webinars, click on past, and you'll be able to see any of our webinars, or go to our resources tab, and they're all listed there as well. We want to thank you for joining us today, and have a great rest of your week.